Right, now we're getting to some heavier topics. We're going to talk about animal products in our century, and I've titled it, Sitting on a Time Bomb. Just once again to show you the university where some of this research will have been done. The major cancers in Western society, pancreas cancer, prostate cancer, colorectal cancer in males are the three cancers that affect males largely. Prostate cancer in old age is very, very prevalent. And colorectal cancer in the Middle Ages and also in old age, very prevalent. And these are lifestyle diseases, as we have seen in the previous lecture already. In women, it's pancreas, breast, and colorectal cancer, the same three, with colorectal cancer playing a very prominent role in old age amongst the women. And in the last lecture, we already saw that these diseases are lifestyle-related because the Japanese caught up with Western society as they changed from the one to the other in both the males and the females. Now, here is the Foundation for Prostate Research in Japan, and one of their spokesmen says, Japanese are eating more meat these days than in the past, so the cases of fat-related diseases such as breast, colon, prostate cancer have increased. They're well aware of what the real problem is, and in our last lecture we already looked at what afflictions cause the main incidences of death in the United States, and we saw that the lifestyle diseases, heart vascular, cancer, and chronic lung diseases were the top three in that category, and poor diet and inadequate exercise was the number one cause for disease. Now, meat consumption is one of the components that contributes greatly to disease in the world. Here's a graph of per capita meat consumption versus colorectal cancer. And again, the higher the meat consumption per nation, the greater the incidence of this cancer. New Zealand, of course, is the meat-eating country in the world. I think only the Afrikaner nation in southern Africa can compete with the New Zealanders in terms of eating meat. Not even the United States comes close to the New Zealanders. New Zealanders believe that chicken is a vegetable. And meat consumption, just to refresh your minds, fish gave an acid load of 7.9 milliequivalents, and meat in particular is problematic because when you heat oils and fats and meat proteins together, you get substances that form which are called heterocyclic amines. So when you do a barbecue, then these compounds, for example, form, or when you make a roast in the oven, and these compounds are these ring-structured nitrogen-containing compounds which are known to be carcinogenic. Some are worse than others, but generally speaking, they're all quite bad. Here is one, A-alpha-C, looks like this, three little rings next to each other. There's a glue P2. They're very similar in structure. It's just the little bonds sit in different places. And if you take a typical piece of meat of any kind, a piece of broiled beef will have 651 micrograms per portion per 100 grams of this A-alpha-C product, the methylated form of that, and down the list, broiled chicken, 180, and as you go to sun-dried sardines, it has 158 micrograms of IQ, and all these compounds occur in these products. So obviously, the more you eat, the higher your risk category. It doesn't mean you will get the disease, it just puts you in a higher risk category. Of course, you can also eat anti-carcinogens with it. That lowers the risk category again. Animal proteins and lymph gland cancer is also highly correlated. New Zealand and the USA, Denmark lead the pack over there in terms of per capita bovine protein consumption, that's beef consumption. And interestingly, this is a huge study that was done comparing vegetarians with non-vegetarians. People that consumed meat more than 4 times per week, notice how diabetes starts increasing after that. So if you consumed meat 6 times per week, you had 4 times the risk of getting diabetes to if you did not do that. So amazing correlations between meat consumption and various lifestyle diseases. Other diseases like ovarian cancer, heart disease are mildly also correlated, and the risk increases relative. A risk of 1 means no risk, because if you have 2 groups, 10 in the group, 1 gets sick here, 1 gets sick there, 1 divided by 1 means 1, no difference, you see? Anything more than 1, that gets problematic. So once you get to 2, 3, 4, then you really have to start taking notes. Now, if we look at our digestive systems, the digestive system of the human is more like that of a fruitarian who also consumes grains. And the stomach is the organ in which protein digestion takes place. And here in the stomach, you have acidity. That's the one place where you have acid, and which enables you to digest your protein. If you put a plant protein in there, then because of the way in which the plant protein is structured, the digestion time is relatively short, and you don't need a very acid medium in order to do that. As soon as you start putting a plant protein in there, it is evacuated quite quickly through the duodenum, and after a few hours, 3-4 hours max, it's out. If you put an animal protein in there, like beef, for example, or meat, it can stay there for 6 hours. If you put a protein in there, like casein, for example, it can stay there for 10 hours or even longer. So that means a lot more acid exposure time, and also a lot of fermentation time going into that. So basically, the less animal protein you put in there, the better. Another problem is that as the product moves out, it is analyzed up here in the upper end of the small intestine to see how far the digestion has progressed. So there are receptors that measure that and send impulses back, keeping the stomach closed for longer periods of time. In other words, if you are going to mix, for example, fruits and meats together, or plant products and animal products together, the digestion time in the stomach is determined by the longest link in the chain. So let's say you're putting the things in there together, and the animal protein takes 6 hours to digest, and everything else is finished after 3 to 4 hours. That means that's 2 hours of fermentation time left over, and you're getting fermentation products rather than the actual nutrients that you should be getting. So whenever you mix animal proteins with a meal, it makes the digestion problematic. In the past, they used to divide the plate into 4. They called that basic 4 diet, and they say you have quarter vegetables, quarter meat, quarter dairy, and quarter grains, and things like that. These days, they don't do that anymore. They say your main diet should be at the base, your grains and your cereals, then your fruits and your vegetables, and then they say your meats, and then your fats and your oils. And even this, of course, is not the best way to put it, and the reason for that is as soon as you add meats to your diet, you have all these problems. But there's another problem with animal products, and that is biological magnification. Now, what does that mean? Basically, in any food chain, as you go up the food chain, you concentrate toxins. So let's take a toxin like DDT, for example. If it's in the water at this very low concentration of 0.000003 parts per million, as soon as you go to the next level in the food chain, it rises to 0.04 Now you will notice that that is a very considerable. Your 2 decimal places there and your 2, 4, 6 decimal places, you've shifted 4 decimal places. That's a 10,000 times concentrating ability. So the toxin is concentrated there, just concentrated again, again, and again. And by the time you get to the top of the food chain, you can have a couple of million times concentration of those toxins. So when birds, for example, pelicans, feed on marine life or fish or whatever, then their shells of their eggs become so thin that when they sit on them, they actually crush them because of the high levels of toxins, and then these animals start dying. Now, exactly the same happens in modern animal husbandry. You see, modern animal husbandry, farming techniques today with farm lots is totally different to what it was like in the past. And you can get tremendous concentrations of toxins as you go up the food chain. People always say to me, well, what's the difference? You know, plants get sprayed. Yes, that's true. Plants get sprayed. But animals eat sprays all the time. And when a cow grazes in an area where some areas have been sprayed, some of those toxins end up on the fields, and the animal grazes this, then because they eat every single day, they accumulate and multiply the toxins, and they end up in the tissues. So the levels of pesticides, for example, in animal products can be higher than on some plants that are sprayed directly. And then you have another problem. Plants don't get their organic matter from the ground. Where do plants get their organic matter? They get it out of the atmosphere, carbon dioxide and photosynthesis. So they build their own organic matter. So whereas an animal will eat a plant or eat another animal and actually incorporates that creature into its system, and any toxins there get accumulated as you go up the food chain. So you're still best off with a plant product. Now, modern animal husbandry has the problem that they create feed and feed the animals, and sometimes these feeds are not what the animal was originally designed to consume. So, for example, in the industry, over years, they have adopted the idea that the rumen, the fermentation chamber, is a place where you can put just about anything. So, for example, you can use chicken manure, which is rich in uric acid as the excretory product, because there are bacteria up there that will change that uric acid back to protein, break it down, and enable the bacteria to build protein. So you can give them cheap chicken manure. But that chicken manure also contains other compounds, the waste products of the chicken, and any drugs that the chicken has had will be incorporated into that. That gets built into the tissues, and when you're actually buying the meat, you're not just buying meat, you're buying accumulated toxins and consumer drugs added to the system, built right in. Now, we did a lot of research with these companies. I was in the fortunate position that being at a university from the previously disadvantaged society in Southern Africa, that I could get my students to do research in just about any institute, because I could put any company between a rock and a hard place. If I said to them, I would like to come and do research at your site, and I'd like to use your animals that you are using in the industry as research objects, they would naturally be inclined to say, no, you've got no right on my premises. And so I just played my trump card. And I say, are you telling that you're not willing to help students from the previously disadvantaged society? And then they'd be between a rock and a hard place, and they'd say, well, and then I'd just go in and I'd do it. So it might seem sometimes as if the research is wicked, but in actual fact what you are doing is you are just going along with industry. These animals would have gone through that process anyway, And half of the animals are always placed in a better position than they would have been before. So I don't like animal experimentation, but this is one way in which you don't initiate it, you're just working with industry itself. Today, animals are fed anything from antibiotics to petrochemical waste to all kinds of manipulants. For example, in the chicken industry, certain grains are cheaper at some seasons than others. Certain grains are just generally cheaper, like wheat would be cheaper than maize. Chickens don't digest wheat very readily, and so they just create enzymes which help them to get along with that. So you have designer enzymes which you give the animals, which help them to digest the feed so that you can give them a lower cost feed in order to get greater production. Irrespective of the fact that those designer enzymes will cause internal bleeding in those animals, that's besides the point. Who cares? As long as they still grow adequately to give you a return on the money. That's how it basically works. And I just thought I'd keep this in because I like the language. Beestevrak van voermengsel, which simply means cattle are dying from the feed that they are getting. These cattle were being fed chicken manure, which contained a monoenzyme, ionophore, which was used as a growth promoter for the chickens, and the cattle were dying of this growth promoter. Fortunately, he managed to get most of his cattle to the market before they died, but, it's a serious blow to lose all your cattle. What about that fortunately? That means who was consuming in a still higher capacity what was in those animals? The human beings. So it goes down the food chain. Fear in the food chain. Toxins in Belgian chickens set off another wave of anxiety in Europe. In this case, it was dioxin, which was in the food chain. It ended up in the food chain of pigs, and it ended up in the food chain of the chickens, and it causes cancer, of course, highly carcinogenic substance. This is a typical experimental setup where they keep chickens in feedlots like these, and in a normal chicken lot in industry, it'll look like this in a egg-laying situation where you'll put more chickens into a cage than the cage can accommodate, so that they're always squashed, so that no energy gets lost in terms of movement and the other, and all they are is they become egg-laying machines. Here's one of the industries where I was working with these chickens. This was one of my PhD students there. There's another one. And we were feeding these chickens like industry feeds them. Now, industry has different setups in different organizations. In this particular setup, they were using as one of the main feed items fish meal. Fish meal mixed with grains. And we said, all right, we want to compare that with a feed that contains no fish meal, no animal products. So we balanced the meals and got the equivalent proteins and all the parameters exactly the same, but the one got a protein group that came from animal protein, and the other one that got protein group that came from plant protein. And typically, this is what a chicken would look like very often if it got the animal protein. Notice the decalcified legs. These chickens couldn't walk properly. Now, if you get a drumstick, you wouldn't really notice that, right? So who cares that they are like that? But the fact of the matter is that the animal protein was causing decalcification. Then there was something else that we did. This is the end process, where you go through the abattoir process and collect the blood at the end of the process and write up all the experimentation. This was my Nigerian student. And what happens in these lots is really fascinating. You see, they found out that in order to prevent disease, it's good to give low levels of antibiotics as a preventive. And there's a spin-off that makes it economically viable. If you add the antibiotics, then you're shunting energy away from the immune system, and that goes into growth. So antibiotics in low levels act as growth promoters for chickens. So the chickens invariably get fed these low levels of antibiotics. And we were convinced that these low level of antibiotics will eventually cause resistance to antibiotics. And so should somebody consume that chicken and he would be infected, let's say, by a salmonella or one of these bacteria in the chicken, then he would not be able to be treated when he gets to the stage of actually contracting the disease from these bacteria. When they go through this process, their beaks are burnt away so that they do not hurt each other. They are crowded into areas. And then, of course, the probability of salmonella outbreak is very high. Health alert of a chicken, salmonella outbreak in flocks. And other diseases like encephalitis diseases become very common as well. So in Hong Kong, for example, just a few years ago, they had to kill every single chicken in Hong Kong. And then again, with the next outbreak of flus, they have to kill every single chicken in Hong Kong. In Malaysia, they had to kill every single pig in the south of Malaysia because of encephalitic diseases. This means these are diseases that are transferred from the animal to man and causes encephalitis in man. That's brain fever. And most of those people can die from it. They can be retarded if they survive, permanently disabled, or they die. So, very dangerous diseases that are transferable from animals these days. Hard to swallow. Here are all these chickens that are being fed these low levels of antibiotics. Here are some other drugs that are used in the animal industry. Clenbuterol, for example, is a drug that is used in cattle to make them grow faster, but it is a highly dangerous drug for human consumption, and it's banned in most countries. But here you can see that even in countries like Germany, they have regular scandals where farmers are actually using these on the black market. See, if you can get your cattle to go on the market 1 month earlier, and if you have 1,000 head of cattle, that's a huge financial saving. So obviously, if you can use this clandestinely, then well. Now they test for clenbuterol quite regularly in Europe, but in other countries they don't. In my country, they don't test for clenbuterol. Only the meat that is sent to Europe is tested for clenbuterol, but not that which is used on the local market. So you don't know whether you're getting these drugs or whether you're not, or what doping takes place in the cowshed. These little animals here are raised never to move, because then the meat stays tender. In fact, in order to grow quickly, they are squashed in so that they can never even lie down. They have to stand their whole life just to be slaughtered. Huh? My fonts have gone crazy. I'll have to live with that. Hard to swallow. This should be a delta. The T delta S factor. Delta H equals delta F plus T delta S. Now, actually, that looks complicated, but it's not complicated. H is the total energy. F is the energy that goes into growth. And T delta S is the energy that is wasted in terms of movement and reproduction and thermoregulation and all the activities that make an animal an animal. So obviously, if you want the energy you feed to go into growth, then you have to limit that. So you put the animal in a cage that it cannot move. And if it cannot move, it doesn't waste energy. You control the temperature, it doesn't have to waste energy on that. You keep the males and the females separate, they don't waste energy even just looking over the fence, you know what I mean? So that's how you keep them, and that's how you grow them, and that is modern animal husbandry. And then, of course, in these crowded environments, you stick to these antibiotics. Here was the case of burying the bacon. Did human error help spread a virus from pigs? So the encephalitis virus is these days very common in pigs. So we don't even worry about African porcine diseases and all the other parasitic diseases in pigs anymore. The big problem is really the viral and bacterial diseases that we can get today. Japanese encephalitis, a deadly disease, is spreading amongst farmers. And so they had to go and kill 300,000 animals, 10% of all the pigs in Malaysia. Even the medical world is saying pig transplants should be banned. You know, the heart valves, etc., that they use to replace heart valves in humans? You shouldn't do that anymore because the virus could be in there and your heart might function perfectly, but you die of encephalitis. So meat is not what it used to be in the old days, and a slice of pork or a slice of animal today is a product of the injection more than anything else. These were the world's deadliest scourges, other now than cancer, heart disease, and all of those. The number one killer of the infectious diseases is acute respiratory infection. In fact, bacterial or viral, that kills about 4.3 million people every year. Diarrhea, 3.2 million. TB, 3 million. Hepatitis B, malaria, measles, etc., goes down the list. So if you look at the first three, acute respiratory infection, diarrhea, and tuberculosis, all three of them are transmitted by animals. All three. TB you get in animal products, in dairy products in particular. Diarrhea is caused by bacteria, largely bacteria from animal products, so dairy products and meat products, some of it also from contaminated water, but most of these and the respiratory infections are because of lowered immune response, which makes it possible for these to come in. So if we look at the mid-80s, you'll see that bacterial infections started increasing on our planet in the mid-80s. So they just soared. That's Campylobacter. That's a bacterium found largely in chicken that causes diarrhea. Salmonella is, of course, the other one, food poisoning. Also started increases since the mid-80s. And if we look at the veterinary record from 1985, they'll tell you what they were suspecting, that antibiotics were being used to counter husbandry practices. So they did an analysis of antibiotics found in beef and chicken and found penicillin, tetracycline, streptomycin, and all of these antibiotics. Penicillin they didn't find in the mid-80s anymore because it wasn't used anymore. It didn't work anymore. So these are the ones that were mainly used. In beef, it was tetracycline, streptomycin, chloramphenicol, and gentamicin. And in any sample tested, in 86% of any random beef sample, you found that antibiotic. In chickens, the percentages were up to the 90%. So streptomycin you'd find in 93% of any random chicken. And in fact, in beef, you would find largely 2 different, sometimes 3, occasionally 4 antibiotics. And in chickens, you'd find largely 3 different antibiotics used at the same time. It's really quite incredible. Now, we had contended for many, many years that antibiotic resistance comes from the farm. And then the farmers said, no, it's from the medical world. The medical world is using these drugs on humans, and that's why it's a problem. And the medical world said, no, 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 it's the farmer that is using it. So the pot was calling the kettle black and vice versa. So we designed a very simple experiment to actually settle the question. Where did it come from? Antibiotic resistance bacteria in the 80s in Mexico showed penicillin 100% resistance. All these bacteria, whatever they were, from Staphylococcus to Salmonellas, all of them were up to 100% resistance. So penicillin didn't work at all in the mid-80s. When it came to the others, they were sometimes effective, sometimes not. And so how can this antibiotic resistance affect you? So by the 90s, 1991, 92, suddenly mystery infections in hospitals started to kill people. And then it started increasing to an epidemic. Animal antibiotics threaten hospital epidemics. And what was the problem? the killers within, all these bacteria, were now resistant to antibiotics. And then the first epidemic started coming in the late 90s, and the children are dying. An epidemic of food poisoning is only the latest Japanese disaster. And the Japanese Minister of Health was walking around with these thousands of children, all sick and dying. What happened here was that there was this major disaster of beef that had been contaminated with E. coli. And after school, little children went home from Sakai, and they came down with this sickness, an epidemic that the World Health Organization declared unprecedented in modern history. 8,500 people in the one little village, and it was an ordinary E. coli bacterium that caused the problem. Children complained of vomiting, diarrhea. Doctors, assuming they were treating simple food poisoning, gave them antibiotics and sent them home. And did the antibiotics work? Of course not. Why not? Because the bacteria were resistant to antibiotics. They'd come out of the system. So the epidemic became a painful blow to the Japanese psyche. Thousands of people sick. The Spiegel came up with an article, Deadly Eggs, and packed the eggs in a little coffin. And the question was, is it still safe to eat eggs? Then legislation started coming in. In Europe today, you cannot order an eggnog. You cannot order a Sunnyside egg from a restaurant. If you go to France and you order a Sunnyside egg with the yolk soft, you go to jail if the cook gives it to you. He's not allowed to. It's against the law. So nothing is what it was before. Spain started introducing legislation. Then Belgium. Eventually it spread to the whole of Europe. Days per week egg consumed, and you start seeing that there's a correlation also between prostate cancer, colon cancer, and egg consumption and ovarian cancer, very highly correlated. So the more eggs a woman eats, the higher the correlation of ovarian cancer. That's besides the salmonella problem in the eggs. And here's another Afrikaans one, besmetting van hoendereiers brei landwyd uit. So the chickens started getting sick all over the world. Superbugs were coming into the world. And this is a journal, Science, which reported that most of the diseases from the Campylobacter, Salmonella, E. coli, Listeria, that's a bad one over there. If you get Listeria infection, you can go blind. If you are pregnant, you can give birth to stillborn babies, deformed babies, terrible one to get. Most of it comes from poultry, raw milk, untreated water, eggs, poultry, meat, ground beef, raw milk, ready-to-eat foods, seafoods. Those are the number one causes of these infections. So we wanted to solve the problem. Is it from the farm or is it from the medical world? So we designed a very simple experiment. We were actually the first ones to show this. We're quite pleased with that. And we did this little experiment. We went to an abattoir and reasoned, if we take a sample of the animals as they come from the farm, and we analyze that meat for antibiotic resistance of the bacteria in that meat, and we compare it, let's say, with a retailer, where the meat has now been handled by many people down the chain until it's finally on the supermarket shelf, we should find the following. For example, let's take any one of them, Staphylococcus. And we see in the abattoir, we found that the bacteria, as they came from the abattoir, showed a 90.5% resistance to tetracycline. But when we went to the retailer, we found only a 79.5% resistance. And that was kind of consistent all along the line. 7.9 versus 3.9, 93.7 versus 72.4, 14.3 versus 7, 17.5 versus 14.1. So the resistance was always higher at the abattoir level than at the retail level. And that told us where it came from. It came from the farm. You see, the animals came from the farm. We analyzed the bacteria. They were highly resistant. Now, humans have the same bacteria. We also have Staphylococcus bacteria in us. Now, when we handle the meat and it goes down the food line processing, eventually to the retailer, bacteria from humans are added. So if the resistance goes down, that means less resistant bacteria were added. If the resistance had gone up that way, that means more resistant bacteria had been added. So a simple experiment like this proved that the resistance came from the farm. And we published this, and all hell broke loose. You can imagine the farming lobbies, how angry they were that we had claimed that we can prove that it comes from the farm. And really bad news. So basically, when you eat this product with its antibiotic, then the bacteria that you get is problematic. Now, think about this. You have a little child, and that little child has an ear infection. You go to the doctor prescribes an antibiotic, the ear infection gets better because the antibiotic is going to kill the bacteria. Does it only kill those bacteria, or does it also knock all the bacteria in your body? Knocks them all. So now while you're on the antibiotic, you have fewer bacteria than normal. Is that right? And now let's say the child drinks a glass of milk or eats an egg, and there's a salmonella in there, and it gets into the body, and here it finds few bacteria to compete with it. So that means he's quite happy to increase in there. And the bacteria that are present are all kind of woozy because they're on antibiotics, but this new guy that came in from the glass of milk or the egg, he doesn't care about the antibiotic. Why not? He's become resistant, so he takes over. So all of a sudden the child gets what? Diarrhea. Now you go to the doctor and you say, the ear is better, but the child's got diarrhea. What's the doctor give him? An antibiotic. And will it react or not? No. Now you see, that's okay if you're an adult. An adult has a big body and a lot of water in this body, and if you have diarrhea and you get sick from this, well, you have a fair amount of reserves in your body. But if you're a little kid, then your reserves are gone very quickly, just by reason of size. If you're old and frail and weak, you don't have any resistance either. So who will be knocked most by antibiotic resistance? Little children and old, frail people. They will die like flies, and there's nothing that we will be able to do about it. So if a wave of new infectious diseases comes along, like SARS, for example, or any one of those like are very prevalent today, and we do not have the medication to treat them, and we do not have an immune capacity that's functioning properly, then we're in trouble. So the solution to living in today's world is keep your immune system high. That means no additives in your food, lots of fruits and vegetables in your food, and stay away from the acid-forming foods like the animal products, and you will be better off. The inedible beef stew, well, beef was withdrawn here in the United States and all over the world. We've had mega epidemics in Scotland, in Switzerland, all over the place, killers all around. We're not living in the same society that Grandpa and Grandma lived in. So what do people say? People say, well, we'll have to give up these meats that are dangerous, we'll switch to the exotics. So they start switching to ostrich meat, which is booming industry. Do you know that these animals are very highly susceptible to Ebola viruses and things like that? When you get those, you're dead. You're dead. And then bacteria that outwitted antibiotics started causing streptococci, started causing rotting flesh on the body and all kinds of problems. Malaria is back with a vengeance. Why? Because the host, and not only the host, but also the vector, have become immune to the medication that is being used in the world today. So you know what our science has done over the last few decades? Science has brilliantly given mankind a suspended sentence. That's what it's done. It's put in medications in the world which has kept all these infections at bay until all the organisms have now basically reached a point where they are resistant to most of what we have in the world today. And we are sitting on the brink of what could become an explosion of epidemics, because the animals have started to outwit our drugs. And it's not so easy to develop new potent antibiotics. So we're living in a different society to grandpa and grandma. Then, how safe is seafood these days? People say, well, I'll be a seafood consumer. Here's a typical market of seafood. Beaches hit by health ban. The poisoned Amazon. Cholera makes a comeback. And then the seals started dying. In their thousands, they started washing up on the beaches. In pristine areas, such as, for example, along the coast, the west coast of Africa. No industries, no nothing. And the animals started dying like flies. Why? Then the people say, but these animals are undernourished, that's why they're dying. They were dying actually of pneumonia. That's what they were dying of, pneumonia. And if you look at them, they don't look very undernourished, not at all. But there are certain chemicals in the water that didn't exist in the water a few decades ago. For example, there's a chemical in the water called TBT, tributyl tin. It's a compound that they add to the paint of ships, oil tankers. It's only permitted for oil tankers, where they paint the oil tanker to keep the barnacles from growing on the oil tanker. All others must be scraped manually to clear the barnacles off. But this compound keeps the barnacles off because it's hard with the oil tanker to clear it. Now, the concentration in the ocean is very, very low. I mean, it's incredibly low. But as you go up the food chain, it gets concentrated, and a seal can actually have up to 50 micrograms per 100 grams in its fat. So, what happens? The seal is swimming around, he's normally quite wholesomely happy, nothing wrong with him, and the toxin is stored in his fat. And now there is a lull in the fish. Let's say for a day or two the fish are scarce, or for a few days. What does he live on during that scarcity? His fat. So he burns his fat. And as he burns it, the TBT leaks into the blood system. And when it's in the blood system, the immune system goes. Out goes the immune system. And the infectious bacteria come in, and he has no resistance, and he gets pneumonia, and he dies. So now imagine, where did they get their TBT from? From the fish that they were eating. So now imagine you start eating fish regularly. That means you get those same compounds that the seals are getting, plus the PCBs and all the other compounds that are in there. And where do you store them? In your fat. And now you're fine, because they are basically out of the way. You've stored them in your fat. And then one day, you get sick. You get a normal flu, and you're feeling lousy, and you have a bit of a temperature, and you're lying in bed, and you're starting to burn up, and you stay in bed. And you're not hungry, and you have a temperature. What do you burn in order to supply that energy? Your fat. And what happens to those compounds? They leak into your blood. And what does that do to your immune system? Knocks it out. And then you get super sick. Then all of a sudden, instead of just having a flu and a cold, you actually start coughing like crazy, and you end up with pneumonia, eventually double pneumonia, and you're in the hospital, and everybody says, you know, the bugs are getting tougher these days. No. The bugs are not getting that much tougher. Our ability to cope with them is getting poorer. Does that make sense? Our ability to cope with them is getting poorer. People that go on a healthy lifestyle and they start losing weight, they get sick like dogs. Why? Because all those accumulated toxins are entering into the body and knocking out the immune system and they're sick, and they say, whoa, I better get back to my normal diet. The way to do it is to reduce slowly and effectively and drink lots and lots of fluids and detoxifying liquids to wash that stuff out of your system, and then start life with clean fat thereafter. Omega-3 fats. Don't they tell you that you have to have fish in order to get your omega-3s? Yes or no? Well, we'll be dealing with that in the next session. In our previous session, we saw that accumulated toxins can affect our health because we can concentrate them when we consume them from animal products. And so we saw that fish in particular accumulate many of these toxins from the marine environment. But we are told also by the scientific world that we need omega-3 fats in our diets, and the best place to get them, the world tells us, is from what? Fish. Right. Now, is that true or is that not true? Now, let's just briefly look at this. Let's look at the general fish situation. Cholesterol content of various fishes and fish oils and beef, for example. Beef has 79 milligrams of cholesterol, 115 for herring oil, 73 salmon oil, sardine oil 106, and cod liver oil 86. So just as much cholesterol in fish as in anything else. When we look at the omega-3 fats, yes, they are very important. They help to decrease the stickiness of the platelets and the blood clotting cells. They tend to decrease blood pressure. They tend to decrease serum triglycerides. Those are the fat molecules in the blood. If a heart attack does occur, they may decrease the muscular damage, and they appear to decrease the likelihood of blood vessels blocking up after bypass surgery. So omega-3s are good, and they are healthy, and we need them in the diet, and we are told fish is the best place to get them. What disorders may benefit from omega-3s? Rheumatoid arthritis. You want high omega-3s in your diet there. Primary Raynaud's disease, psoriasis, gastric intestinal diseases. So these are skin diseases, and these are intestinal diseases, Crohn's disease. These are nervous diseases, depression, overaggressiveness, carcinomas, that's cancers, and various pulmonary diseases. So, omegas are very good for you. Here's the metabolic pathway. The first fatty acid that we're dealing with here is alpha-linolenic fatty acid. Now, that is one of the essential fatty acids that we find in plants. And these are converted by an enzyme, which is called delta-6 desaturase, and another enzyme called elongase, and another one until we get a fat called eicosapentaenoic acid. Now, that one up here, alpha-linolenic acid, is an omega fatty acid, and eicosapentaenoic acid is another one. Now, this one over here, eicosapentaenoic acid, is the one that you find in fish. That's the one you find in plants. So plants have alpha-linolenic, and fish have eicosapentaenoic acid. So if you were to get your omega fatty acids from plants, that's the one you'd get. Then you have the enzymes in your system to convert that, as you need it, into that. Does that make sense? All right. Now, eicosapentaenoic acid is the one that determines the fluidity of your blood, for example. And should you get too much of this, what would be the risk factors? Thrombosis, strokes, all kinds of problems from too much eicosapentaenoic acid. So plants don't have eicosapentaenoic acid. And if the argument were true that we have to get our omega fats from fish, then the same argument must be true for every other animal on the planet. That means an elephant and every ungulate in the world and every herbivore in the world should actually eat fish. But they don't. They consume alpha-linolenic acid. And then they make as much eicosapentaenoic acid as the body needs, and therefore you would never go into a risk category for strokes or thrombosis or other diseases like that. So what's better? Getting it from a plant or getting it from a fish? Getting it from a plant. Or else, if you believe that God created this world, you would have to say that God was stupid, because he didn't put any eicosapentaenoic acid into the plants, which is the basis of the food chain. He put alpha-linolenic into the plants, and alpha-linolenic doesn't cause a problem. It's the other one that causes the problem. In fact, alpha-linolenic is the one that you will use not only to make eicosapentaenoic acid, but to make all the other things as well, like prostaglandins and all of those compounds that we need. That's the basis. We need this one. We don't need this one as the basis from which to work. We can't work back. We can only work this way. So, what plant foods contain omega-3 linolenic acid, for example? Which ones? Roasted potatoes, if we look at the vegetable world, cucumbers and all of those, sweet potatoes, bananas, California avocados, they have 99, 74, etc. That's not very, very high. Whole wheat bread has 11. And are there any others that are higher than that? Well, actually, yes. As we go to the nuts and the dark greens and the legumes, whoa, now we're climbing. 136, 353, 637 for green soybeans. Soybean oils, 927. Whoa. Wheat germ oil, 938. Walnuts, 1,033. Canola oil, 1,094. Walnuts, English, 1,703. And who's the super king in the world? Flax seeds, 7,526. So if you add your flax seeds ground to your cereals or to your breads or to your whatever, do you think you're going to have a shortage? I somehow doubt it. And there is no animal that will compete with that. And you're getting what you need. So you can get it from plants. Don't believe that you cannot get it from plants and that you have to get it from fish. Evidence linking fish contamination to cancer. Number one, elevated levels of pesticide compounds have been found in the tissues and breasts of cancer patients. National Cancer Institute shows an increased death rate from cancer amongst people living in areas where fish have exceptionally large numbers of tumors. Fish have more cancer than 50 years ago. For example, 30% of bullheads in Lake Erie were found with liver cancer. That's pretty scary. And PCBs, PCB exposure in the general population comes from fish, may affect sperm counts, fertility. Pregnant mothers are linked to alterations in birth size, etc., from PCBs. And children at 11 years of age with higher exposure to PCBs before birth show impaired intellectual development. And you might think, well, you know, I eat fish from deep water. I'll buy only deep water fish. So people buy deep water hake, deep water salmon, deep water this. Well, where's the biggest contamination today? Here are the Arctic people up here, living in these areas up here, where they are far removed from any industry. And at risk, the Inuits' diet is contaminated with pesticides, PCBs, and other poisons right up there. The highest levels these people have because that's their main diet. Fascinating. So there's a fish today with typical tumor fish, new scientists, parasites for supper. The fish too, of course, have a reduced immune system, and so they are getting more parasites than before. Mystery killer stalks Australian waters, new parasites that we never even knew about affecting these fish. These fish develop aganodia. They don't develop any sex organs. If we look at the decline in fishing over the years, we'll also find something else, that oil ratios in fish have declined since the 80s to the 90s. That means the fish are not storing energy like they used to in the past. That means that they are generally diseased. And so up until the 90s, we find an increase, with a peak increase suddenly in 88, of what we call atresia. That means these animals actually start producing eggs, but they haven't got the energy to finish the process, so off it goes again. The fish world, since the 80s, when the high industry toxins started taking their toll, is not what it used to be. I'm always a bit worried when they come out already fried. Yeah. So it seems that the general food structure in the world, the feedlot structure, animal husbandry, the fishing world is a problem. And then we have some new exciting occurrences. Mad brains, mad cow's disease. In humans, it's called Creutzfeldt-Jakob syndrome. And what caused it, they found, was a prion. Now, many, many years ago, we started lecturing about these issues, and many years ago, you can check old tapes of ours, started warning that these things would become epidemics. People were laughing at us. I'm talking about 12, 15 years ago. Today, nobody laughs anymore. Prion disease, what's that? A prion is a tiny little protein that occurs in the brain. Millions and millions of proteins called prions live in the brain. And the normal one looks like a double helix. And an abnormal one, the protein has flattened out into sheets. We'll look at that in a moment. And suddenly the animals started going crazy. Cattle would start bashing their heads against the walls, and then they would start foaming and falling over, and they would go mad. Now what happened? Normally prions, depicted here by these little blue proteins, occur in the brain between nerve cells, and they form important functions to help transmit impulses and other activities in the brain. And as I said, normally they have this helix structure. They are twisted like that. Now occasionally it can happen that a prion becomes abnormal, and then it flattens out into a sheet, and it looks like this, a converted prion. And suddenly it is different. It adheres differently. Its charge is different. And instead of lying between the nerve cells like this, it actually goes and sits on the nerve cell. It packs onto the nerve cell. Later it covers the whole nerve cell, and that nerve cell cannot exchange oxygen anymore, and it dies. And when it dies, it gets resorbed, and then there's a little hole where the nerve cell was. And eventually a lot of nerve cells start dying, and then the whole brain gets full of holes, and it starts looking like a sponge. That's why it's called a spongiform disease, like a sponge. Bovine means cattle, spongivore, encephalus, brain inside the head, literally means cattle with sponge brains. That's what it means. And they said, well, that's too bad for the cattle, but fortunately not too bad for us. It just means we have to eat more meat, because all these cattle are going to die, and so we consumed them. And at that time, Major was in England when the epidemic broke out. Major was the Prime Minister, and he said, don't worry, no problem, it cannot affect you, everything's fine. Spiegel didn't believe him and had this little cartoon of him. I've eaten beef all my life, and I can assure you it never caused me any harm, moo. Now, the fact of the matter was that they said, well, this is something to do with the brain, and it won't affect the meat. You'll be fine if you eat the meat. The epidemic started in the 80s. Then by 92, it reached its peak. And thousands of cattle were affected. As were tests that were made. And eventually it came so far that it would kill just about all the cattle in the entire British Isles. And the epidemic was under control by the late 90s. Now, what happened? Notice at the peak of the epidemic, 1992, these were the exports of beef to the rest of Europe. So at the peak of the epidemic, 1992, beef exports just exploded and tripled in millions of tons to Europe. You see, they had a lot of cattle that they had to put down, and so people had to eat this meat. Not only that, what's not shown on this graph is the huge quantities of carcass meal, where they actually condemned them and ground them down and dried them and sent the feed over. And this feed was used in the whole animal industry. It was used for fish farms, it was used for chicken farms, it was used for all of those. And so they started feeding this to these animals. And then the fish started to get what they called staggers. The fish got and they got mad fish disease. And they said, but surely it cannot jump the species barrier. Creutzfeldt-Jakob syndrome, that was the one in humans, that started increasing. Then they said, don't worry. Even if a human can get it, it'll take 80 years to develop. And who cares? After 80 years, you're not going to be around to worry about it anymore. And then the young children started dying. The young people started dying. This one was age 21. That kind of blew the 80-year theory. And by 1994, mad cow's disease passing on to cats. You see, they'd taken the meat, and a lot of it went into the pet industry, and the pets were getting their pet food, and the pets were getting mad cow's disease. So now, they couldn't, by 1994, say that it wasn't crossing the species barrier. So what happens is, when you get this abnormal prion into your system, and it comes into contact with a normal prion, the normal prion becomes abnormal, like a domino effect. The first one hits, and down the line, all your prions become abnormal, and then you've had it. And how quickly can it develop the disease? Well, then the little children started dying. And then they realized, whoa, we have a problem. And then they said, burn them. So they burnt all the cattle on the fields. But unfortunately, they didn't realize that that wasn't hot enough to destroy a prion. You see, a prion is not digested in the intestines, and it's not destroyed by heat. It's too small and too compact. And so, the next season, where this animal died, the grass just grew a little bit better because there was lots of fertilizer there. The cattle came and ate the grass, and they got mad cow's disease. Then they realized, we better incinerate the cattle. That was very expensive. So they incinerated the cattle, but by then the first baby was born with Creutzfeldt-Jakob syndrome. So babies were born with it. Here is a brain scan of a 17-year-old with Creutzfeldt-Jakob. That's the destroyed portion of the brain over there. There was a picture of the month in February 2001. Little babies with Creutzfeldt-Jakob syndrome. And so they finally realized we cannot feed this to humans, and they condemned everything to be incinerated. But the feed had been exported to just about the entire world. So what had they done with their disease? They'd exported it. And every nation said, it's not a problem. See, first they said, here's the situation. Here's a typical cow, and everything that's red over here, that's where you have 1 billion prions per gram. So avoid anything that's red. So that's the nervous system. Then if you come to what's yellow, the glands and the intestines and the bone marrow, that has 1 million prions per gram. So maybe we should not eat the bones. So they made laws in Europe that you weren't allowed to have a T-bone, for example. You have to cut it off the bone and only eat the meat, because the meat has fewer than 10 prions per gram. So they said, how do you make sausage? You shove it into the intestines, right? So look at that. There you're getting 1 million prions per gram, so there was a problem. And the milk also has 10 prions per gram, but if it's a domino effect, how many prions do you want to get into your brain? I would like to get no abnormal prions to get into my brain. So here's what happens. They started saying, we'll just use the meat and we won't use anything else. Now, how did they process this? This is a typical meat market in Smithfield Market in London. This is how they process the meat. Here the man is sawing it through. There's the carcass. Where does he saw the first cut before they hang it up to saw it up? Right down the middle. Right down the middle. 2 halves. Now, what do they use to cut it? Isn't it a band saw? Now, that's going straight through the billion prions per gram area and smearing it all over the rest. Isn't mankind kind of silly? And so, suddenly, mad cow's disease was not confined to Europe, but also started occurring in Europe. By the way, that's Europa, the prostitute that was raped by Zeus. And confirmed it was bovine spongiform encephalitis. Everybody started banning their meat and saying, no, we only have our meat, we only have our meat. And deadly meat. Suddenly it was deadly eggs, now it was deadly meat. And the United States said, we don't have a problem. Do they have a problem now? Oh, I see. Does Canada have a problem now? Yes. So could mad cow's disease spread further? Yes or no? We've only seen the tip of the iceberg. Then there was a scare in southern Africa, and by the late 90s, it was spreading all over the world. We are sitting on a time bomb. Then, tests could pin down mad sheep risk. It's called scrapie when it's in sheep. And scrapie is very, very prevalent. I was in Iceland at the end of last year. That's just a few months ago. And guess what? Iceland has the strictest rules in terms of meat import or any animal product import. They don't use any compounds from the other countries because they have these stringent rules about preserving their environment. And guess what? They got mad sheep's disease breaking out in Iceland. And they had to destroy an entire herd of one particular farmer. It was interesting to me, very interesting. And so, even in that country, by the late 80s, doctors at the VA hospital in Pennsylvania autopsied 54 demented patients and discovered that 5.5% had died of Creutzfeldt-Jakob disease. While the United States was saying the problem doesn't exist in this country, in 1989, they knew already, published in the journal Neurology, that it was prevalent. Scientific American, 1995, Creutzfeldt-Jakob disease has apparently been transmitted by cornea transplant, brain electrodes, surgical instruments, injection of human growth hormone. Fascinating. The Annals of the New York Academy of Science predict or said ample justification exists for considering a similar pathogenesis for Alzheimer's disease. And then something else started increasing. By 2001, we just got over the major BSE scare, which is not gone, which is just simmering under the surface, waiting to explode, when suddenly there was this tremendous TB shock. Tuberculosis shocks the farmers in Germany. First there was the BSE crisis. Then we had the pig feed crisis, and now we have TB. And this TB is transmittable to humans. And this was thought to be extinct in Germany for many, many years, but suddenly the milk and the meat and all of this contains this bacterium again, and we are at risk from getting TB from these animals. And then foot and mouth disease, Maul- und Klauenseuche, animals, sheep, goats, all these pigs, all these creatures, also the wild animals, started getting foot and mouth disease. And hardest hit again, England. England had just killed all its animals, re-imported new animals, and started the whole industry all over again when suddenly they got foot and mouth disease. Death on the farm. And this is now close to our time. And what did England have to do? Well, England had to kill every single cow and pig and animal in the whole of England. And here you can see the pictures. It was horrendous. And here was the slaughterhouse as they burnt again hundreds of thousands of cattle with foot and mouth disease. And Europe refused to import the meat from England. Now, this is a fascinating story. Now, the rest of the world also got foot and mouth disease. You had an outbreak everywhere. You had it in Australia, you had it in Southern Africa. The outbreak was just about universal. What did the other nations do? The other nations said, well, that's ludicrous. England has got a screw loose. Why kill all these animals and why get rid of all that capital? There's a much easier way to deal with this disease, and this is what the other countries did. They made huge quarantine farms, and they put hundreds of thousands of heads of cattle with foot and mouth disease into quarantine. And then they immunized them all. They immunized them. And then eventually the disease was under control and the problem is solved. So the whole bang shoot was immunized. Now, what does immunization do? Immunization, as the word implies, makes one immune. Is that correct? That's what immunization does. Makes one immune. Does it get rid of the vector, the cause? No, it just makes you immune to the cause. Now, previously, think about this. If the cattle were not immunized and they got foot and mouth disease, you knew that animal was contaminated, right or wrong. And what did they do with it, like they did here in England? Put it down, burn it, and it's gone. If that disease is then not in the other animals, it means none of them have it. Is that right? Now they're all immunized. Do you know whether they're carrying it or not? No. So when you eat it, good appetite. Good appetite. Well, it doesn't kill humans. It doesn't kill humans, they say. It doesn't do that. It just causes blistering and mouth blisters and a terrible flu. That's all. It's not so bad. It won't kill you, so that's not too problematic. But if we go down this line, eventually we can have plasmid transfer between bacteria and other organisms, and they can make new strains of problematic outbreaks like SARS and all of these. What are we actually doing? Keeping an industry alive so that we have the product to eat while we are breeding super killers. Did you know that they are expecting outbreaks that could wipe out whole cities? Did you know that they're expecting that? Why? Just to keep on eating what we ate before? We've already seen in the first lectures that the healthiest diet in the world is a diet that is rich in plant foods. And in fact, most animals in the world subsist largely on plant foods. How much trouble would we avoid if we gave up animal products? Unbelievable. We would benefit on every turn. If we gave up butters, we would have a better cardiovascular system. If we gave up meat, we wouldn't be exposed to these risks that everybody else is exposed to. And we would have a far better capacity to deal with whatever is coming. I'm not saying you won't get sick. I'm just saying you'll have a far better capacity to survive. We're in suspended state of grisly animation. We're just waiting and praying. This is our worst nightmare. And so it started spreading all over the world. And mankind with its drugs is creating a time bomb that sooner or later will explode. Me? Bovine spongiencephalitis? No, I just have a normal foot and mouth disease. And I'm going to export it to the whole world. I like this guy. He's sort of interesting. He's having a typical burger. Do you know that you can have a burger that tastes just as good as that one with a plant-based patty on it, and you wouldn't even know the difference sometimes, and sometimes it would taste better? What skin is it off our nose in the days that we live in with all the culinary expertise that's out there in the world to change the patty and reduce our risk? Doesn't that make sense? Life without Veith. Time magazine had this wonderful picture here with all the vegetables and asked the questions, can plant foods replace meat? Where's the beef? The answer is yes, they can. But the decision as to whether we want to do this or not is ours. So what I've done in this lecture is just shown you the state of affairs in the world to help you make that decision. Whatever that decision is your business and your affair, because let no man tell you your duty. But if you have the facts, don't you have something to base your decision on? So that's what I've done. I've given you the facts, now you can make a decision. Now when we come again together tomorrow, then we're going to deal with something that you really shouldn't miss. Because many of you might say, well, that's okay still, but tomorrow's lecture, well, let's say, don't miss it. It's called Utterly Amazing. And then there is another one which follows that, which will put everything into a perspective so that we're not miserable anymore, but cheerful. Because we'll look at the alternatives and see what we have in store. It really is a magnificent life out there, and nobody should allow diet to make us miserable. You know, some people believe that they get special points when they torture themselves with miserable food. Have you known people like that? They walk around with long faces, and they are extremely health conscious, and sometimes also very judgmental. We don't have to suffer. To suffer is stupidity. Do you think God created man to suffer in terms of the diet? Or did he say it was good, it was very good? What did he say? He said it was good, it was very good. So if it's not very good, we must be doing something wrong, right? So don't miss tomorrow's lectures. We'll look at what there is to do, how to circumvent the problems, and thanks for listening.